for as long as there have been people to look up, one light in the night sky has refused to behave. It is red, the color of rust and blood, and unlike the fixed stars, it wanders, and every civilization that watched it read the same thing into that color: war. This is the story of that red light, the planet we call Mars. But it is really a story about us, about how we looked at a moving dot, and across 3,000 years saw a god, then a dying alien civilization, then a graveyard, then a destination, and how, every time we were wrong, we went anyway. Start at the beginning. To ancient skywatchers, most of the heavens were dependable. The stars turned together night after night in fixed patterns you could set a calendar by. They were the definition of permanence. And then there were a handful of lights that broke the rules. The Greeks called these rule breakers planetesti, the wanderers. 5 of them drifted against the fixed stars, moving on their own schedules. And of the 5, one stood out for its unsettling color, a steady, baleful red that never twinkled, like an ember that would not go out. The Babylonians were among the first to track it with real rigor. Over generations, they recorded its motion so carefully that they knew its rhythms across decades, that it returned to the same place in the sky in a cycle of about 79 years. Patient, meticulous, and centuries ahead of everyone else. And what did they name this red wanderer? Nergal, the god of war, plague, and the underworld. The lord of death. Look at the color, and the choice makes a terrible kind of sense. The reddest thing in the sky became the planet of blood. This was not a one-off. It happened again and again across cultures that had never spoken to each other. The same red light, the same instinct. To the Greeks it was Ares, to the Romans, Mars, the name that stuck, the god of war, whose name the planet still carries today. Think about what that means. Peoples separated by oceans and centuries looked up at the same red dot and independently reached for the same idea: war, blood, danger. The color did the talking. Long before anyone knew what Mars was, they knew what it felt like, and they were projecting. That habit of pouring human meaning into a light we could not actually see is the thread that runs through this entire story. Mars would become a mirror. For thousands of years, whatever humanity most feared or most hoped, we projected onto that little red disk. But the war god had a second strange behavior, one that would torment astronomers for 2,000 years and eventually crack open the entire universe. Because Mars did not just wander, every so often it stopped, turned around, and moved backward. We call it retrograde motion. For most of the year, Mars drifts eastward against the stars, like the sun and moon. But for a few weeks each cycle, it slows, halts, and loops westward, a backward stutter, before resuming its forward march. To ancient eyes, this was baffling. Planets were supposed to be divine and perfect. How can a heavenly body, a god, simply reverse? The dominant answer for over 1,000 years placed the Earth at the dead center of everything, with the sun, moon, and planets circling around us on perfect spheres. It was tidy, it was reassuring, and it could not explain the loops. So, astronomers patched it. To keep the Earth central and the loops explained, they added circles riding on circles, little wheels called epicycles, on which each planet spun as it went around. Mars, the worst offender, needed the most elaborate machinery of all. It sort of worked. With enough epicycles, you could reproduce the loops and even predict them, roughly. But the system grew into a groaning contraption of dozens of circles, tuned and retuned for centuries. It was a machine built to protect an assumption that we were the center rather than to find the truth. And Mars was the crack in it. Of all the planets, Mars fit the perfect circle's worst. Its motion was the most stubborn, the least willing to be tamed. For anyone paying close enough attention, Mars was quietly screaming that something about the whole picture was wrong. But to hear that scream, you needed 2 things almost no one had. First, observations precise enough to catch where the old models failed by the tiniest margins. And second, someone stubborn enough, or tormented enough, to trust those numbers over 2,000 years of comfortable belief. Both of those things arrived at the very end of the 16th century, in the persons of 2 of the strangest characters in the history of science. One had the data, the other had the desperation. Together, and they could barely stand each other, they would go to war with Mars. And out of that war would come the discovery that shattered the perfect circles, dethroned the Earth from the center, and rewrote the laws of the heavens. It began with a nobleman who had lost his nose. His name was Tycho Brahe, a Danish nobleman, brilliant, arrogant, and famously missing part of his nose, which he'd lost in a duel over a mathematical dispute and replaced with a metal prosthetic. He was also the greatest naked-eye astronomer who ever lived. This was before the telescope. Tycho measured the heavens with enormous, exquisitely built instruments of brass and iron, quadrants and sextants taller than a person, and an obsessive care no one had matched. He measured the positions of the planets to a precision of a couple of arc minutes, finer than anyone in history. For decades, night after night, Tycho recorded the position of Mars, the most difficult planet, building the most accurate record of its motion ever assembled. He didn't fully know what he had. He just knew that if anyone was going to solve the heavens, it would be done with numbers this good. But Tycho was a better observer than he was a theorist. He needed a mathematician, someone who could take his mountain of numbers and wring the truth out of it. And in 1600, he hired a young, poor, brilliant, and deeply troubled German named Johannes Kepler. They were a terrible match. Tycho was a wealthy aristocrat who guarded his data jealously, doling it out to Kepler in scraps. Kepler was a mystic and a mathematician of genius who burned to get his hands on all of it. They argued constantly. And then, barely a year later, Tycho suddenly died. On his deathbed, according to the story, Tycho begged Kepler not to let his life's work be for nothing. Kepler, now with access to the priceless observations, took on the problem Tycho had assigned him, the one everyone considered a side project. Work out the orbit of Mars. Kepler was so confident he made a bet with a colleague that he'd crack the orbit of Mars in 8 days. It took him nearly 8 years. He later called the struggle his war with Mars, and it very nearly broke him. Because Mars refused, again and again, to be a circle. Here was the trap. Everyone, Kepler included, knew that the heavens moved in perfect circles. It was more than science, it was almost a religious certainty, 2,000 years old. So Kepler did what any sane astronomer would do. He assumed Mars moved on a circle and tried to fit Tycho's data to it. And he got close. Achingly close. He found a circular orbit that matched almost all of Tycho's observations of Mars, dozens of them, beautifully. It was a triumph. He could have published, taken the credit, and moved on. Almost everything fit. Almost. Because when Kepler checked his beautiful circle against 2 particular observations of Mars, it was off. Not by much. By an amount so tiny that any astronomer before Tycho would never even have noticed it. A sliver of the sky, a discrepancy far smaller than the width of your fingernail held at arm's length. Here is the moment the modern world is born. That gap was smaller than the errors in everyone else's data. Kepler could have blamed it on a bad measurement and buried it. No one would ever have known. But Kepler knew something the rest of the world didn't. Tycho's measurements were too good to be wrong. If Tycho's numbers were that accurate, and Kepler trusted that they were, then that maddening little gap was not an error. It was real. And if it was real, then the circle, the perfect divine circle that everyone had believed in for 2,000 years, was simply wrong. Kepler chose to believe the data. It is hard to overstate how radical this was. He threw away the circle, not because it looked bad, but because it was off by an amount most people couldn't even measure. He trusted a tiny number over an ancient certainty. That is the essence of science, and it had almost never been done before. So Kepler went back to war. If not a circle, then what? He tried egg shapes, ovals, every curve he could imagine, grinding through Tycho's Mars data by hand. No calculator, no computer, just years of relentless arithmetic that filled hundreds of pages. He made mistakes, caught them, started over, and nearly despaired. And finally, the answer surrendered. Mars did not move on a circle. It moved on an ellipse, a gently stretched oval, with the sun sitting not at the center, but off to one side at a point called the focus. A shape so simple that once you see it, the whole tortured system of circles upon circles just melts away. That is Kepler's first law: the planets orbit the sun in ellipses. He also found that Mars speeds up when it's closer to the sun and slows when it's farther. His second law. 2,000 years of epicycles gone, replaced by an oval and a rule. He published it in 1609 in a book he tellingly titled Astronomia Nova, The New Astronomy. Sit with what just happened. The stubbornness of one red planet, the very thing that had made Mars the hardest to explain, was exactly what made it the key. Mars's orbit is more stretched, more elliptical than almost any other planet's. On a rounder orbit, the tiny gap might never have shown up. Mars was the crack that let the light in. And it was won by a man who refused to look away from an inconvenient number. Kepler didn't have a telescope. He didn't have proof of what Mars was. He had Tycho's data, his own desperation, and the courage to let a fingernail width of sky overturn the entire universe. The Earth was no longer the center. The heavens were not perfect circles. But here is the beautiful irony. Kepler had just proven, with ruthless mathematics, that Mars was a world governed by cold physical law, not divine whim. And yet the human habit of seeing what we wanted was about to come roaring back, stronger than ever. Because soon, we would be able to actually look at Mars, and we would see canals. The telescope changed everything. Suddenly, Mars was not a dot but a disk, a tiny, trembling ochre disk, but a real place with features you could actually see. Over the 17th and 18th centuries, astronomers began to map it, dark patches, bright regions, and gleaming white caps at its poles. In the 1770s, the astronomer William Herschel studied those polar caps and watched them grow and shrink with the Martian seasons, just like the ice caps on Earth. He measured the tilt of the planet's axis and found it startlingly similar to ours. Mars, he concluded, likely had seasons and an atmosphere and might well be inhabited. You can feel the pull already. Poles that freeze and thaw. A day nearly the same length as ours. A tilt like Earth's. Mars looked less like an alien god and more like a sibling, a smaller, colder cousin. And if it was like Earth, the thinking went, then surely, like Earth, it might be alive. The mirror was filling up again. Then came 1877, a year when Mars swung especially close to Earth, big and bright in the telescopes. And an Italian astronomer named Giovanni Schiaparelli, using a fine new refractor, produced the most detailed map of Mars anyone had ever made. He covered it in features and he gave them names, including a fateful one. Schiaparelli saw faint straight lines crisscrossing the Martian surface, linking the dark regions. In Italian, he called them canali, which simply means channels, or grooves, a neutral, geological word. He was careful. He did not claim they were built by anyone. But then his word crossed a language barrier, and something was lost in translation. In English, canali became canals, and a canal is not a natural channel. A canal is dug. A canal is engineered. A canal implies canal builders. With a single mistranslation, Schiaparelli's cautious geological lines became evidence of intelligent life, a planet-wide network of artificial waterways. The idea caught fire. And no one caught that fire more completely than a wealthy American named Percival Lowell. Lowell was mesmerized. He was convinced Mars was home to a dying civilization, intelligent Martians on a drying world, digging colossal canals to carry meltwater from the polar caps to their parched cities. To prove it, he built an entire observatory. At his observatory in the high, clear air of Arizona, Lowell spent years staring at Mars and drawing what he saw, or what he believed he saw. His maps grew ever more elaborate, dozens of canals, crossing at precise hubs he called oases, a vast irrigation grid spanning an entire planet. A whole heroic, doomed alien society sketched in ink. Lowell wrote popular books. He gave packed lectures, and the public devoured it. The idea of an ancient, wise, dying Martian race struggling against the death of their world was irresistible, tragic, romantic, and thrilling. For a generation, life on Mars wasn't a fringe idea. It was practically common knowledge. It poured into the culture. In 1898, H.G. Wells published The War of the Worlds and His Martians, cold, superior intellects who cross space to conquer a dying planet dweller's dream of a fresh, wet Earth. Grew directly out of this soil. Mars had become the home of the alien in the human imagination. But there was a problem. Not every astronomer could see the canals. Some looked through equally good telescopes and saw nothing but vague, shifting smudges. The canals seemed to appear only to certain observers on certain nights, at the very edge of visibility, right where the eye is easiest to fool. And that was the clue. When the human eye strains to resolve something at the absolute limit of what it can make out, it does something treacherous. It connects the dots. It takes scattered faint smudges and, hungry for pattern, draws lines between them. Lines that aren't really there. The canals may have been a grand optical illusion, authored by the observer's own mind. It is the oldest theme of this whole story, returning in a new costume. The Babylonians saw a war god in a red color. Lowell saw a dying civilization in a blur of dots. In both cases, Mars was a screen, and humanity projected its own fears and hopes onto it. We were, once again, seeing what we wanted to see. Even Schiaparelli, the man who started it, grew uneasy. He never claimed the lines were artificial, and late in life he suggested they might be an illusion after all. But the dream was bigger than any one scientist now. Only one thing could ever settle it. Not a better telescope on Earth, but going there. Actually going to Mars. For all of human history, that had been impossible. Mars was a light, a disk, a canvas for our imagination, but forever out of reach. You could argue about the canals forever, because no one could ever go and check. And then, in the middle of the 20th century, that changed. We built machines that could leave the Earth. The dream of Martians, the canals, the dying wise civilization, the romance of a living red world had survived for nearly a century. It had inspired novels, panic, and a generation of dreamers. It was about to meet reality. And reality would arrive as 22 grainy black and white photographs. In 1964, NASA launched a small spacecraft called Mariner 4 on a 7-month journey to fly past Mars. The first mission ever to reach it and survive. On board was a simple television camera. Its job was to do what no human eye or Earth telescope ever could: take close-up pictures of the surface of another planet. On July 14th and 15th, 1965, Mariner 4 swept within about 10,000 kilometers of Mars and, for the first time in history, photographed the surface of another planet up close. The data crawled back to Earth over hours, agonizingly slow, a string of numbers that had to be turned into a picture. The engineers were so impatient for that first image that, rather than wait for the computer to process it, some of them printed the raw numbers on a strip of paper and colored them in by hand with pastels, like a paint-by numbers, just to see Mars sooner. And here is what Mariner 4 actually saw, the first close-up photograph of another planet ever taken. Look at it. This is the real image, returned across 60 million kilometers of space in the summer of 1965. There are no canals, there is no dying civilization. There are no cities, no oases, no green fields. There is a bright, dead-looking limb of a world, and as the other frames came in, the truth got starker: craters. Mars was covered in craters like the moon. Cold, cratered, apparently lifeless, and utterly silent. In a single flyby, a century of dreams evaporated. The Mars of Lowell, wise, watery, alive, simply did not exist. The newspapers ran it as a kind of eulogy. Mars was not a living cousin. It looked like a corpse. The most romantic idea in the history of astronomy had died in 22 photographs. It would have been easy to give up on Mars then. The exciting version was gone. What was the point of a dead, cratered rock? But here's the pattern of this whole story. One more time, we were wrong, and we went anyway. Because a lifeless-looking flyby was not the same as knowing. To really know, you had to land. 11 years later, in 1976, NASA did exactly that. Two spacecraft called Viking 1 and Viking 2 became the first landers to touch down safely on Mars and survive. Robotic laboratories sitting on the surface of another world, looking around with cameras and reaching into the soil with a mechanical arm. And for the first time, humanity got to stand on Mars through the eyes of a machine. This is the first photograph ever taken from the surface of Mars, moments after Viking 1 landed, the ground of another planet in daylight, real. And then the landers turned and showed us the view. This is one of the first panoramas of the Martian surface, a rock-strewn, rusty desert stretching to a closed horizon under a pale sky. Not canals, not cities. A landscape. Bleak, beautiful, and undeniably a real place you could imagine standing in. The Vikings carried something extraordinary, a tiny biology laboratory designed to answer the oldest question about Mars directly. Is anything alive? They scooped up Martian soil, fed it nutrients, and watched for the chemical signs of living things, breathing, eating, metabolizing. It was humanity's first real attempt to detect alien life. And one of the experiments, the labeled release test, got a positive signal. The soil gave off exactly the kind of gas you'd expect if something in it was alive and metabolizing the nutrients. For a heart-stopping moment, it looked like the answer might be yes. The scientist who ran it, Gilbert Levin, believed to the end of his life that he had detected life on Mars. But the other instruments disagreed. A separate experiment found no organic molecules in the soil at all. None of the carbon-based building blocks life is made of. Most scientists concluded the signal was probably chemistry, not biology, some strange reactive property of the Martian dirt mimicking life, not life itself. The result was ambiguous. It has stayed ambiguous ever since. And notice what happened yet again. Handed a genuinely uncertain result, humanity split between those who saw life and those who saw plain chemistry, and both were, in part, seeing what they wanted to see. Mars had thrown us one more mirror, subtler than the canals, and we're still arguing about the reflection to this day. What the Vikings did settle was the setting. Mars was cold, far below freezing. Its air was thin, 1/100th of Earth's, and mostly carbon dioxide. Its surface was bathed in ultraviolet radiation and blanketed in rusty iron-rich dust. That's why it's red. It was, for all practical purposes, a frozen desert. But it was our frozen desert to explore, and it held quiet wonders. As the sun set over the Viking and later landers, the Martian sky did something Earth's never does. On Mars, sunsets are blue. The same fine dust that turns the daytime sky butterscotch scatters blue light forward around the setting sun, so the twilight glows with a cool blue halo. On Mars, the day ends in blue. Think about that image for a moment. It is a real photograph, taken by a real robot, of a real sunset on another planet, a blue sun sinking over a rusty desert 60 million kilometers away. A century earlier, we were imagining canals. Now we were watching the sky change color on Mars. The dreaming hadn't stopped. It had just become true. The Vikings fell silent by the early 1980s, and for 2 decades Mars went quiet, a known desert, mapped from orbit but untouched. The romance had cooled, and yet the pull never fully let go. Because the ambiguous life signal still hung there, unanswered. And a cold desert, it turns out, is exactly the kind of place that might hide the fossils of a warmer, wetter past. Because the orbiters kept looking, and from above, they saw something the canals had only pretended to be. Real channels, dried riverbeds, vast outflow valleys and deltas and lake beds carved by flowing water billions of years ago when Mars was warmer, wetter, and had a thicker sky. The canals were fiction. But once, long ago, Mars really did have water. That changed the question entirely. Not, are there Martians building canals, but something deeper and more patient. Was Mars once alive, long ago when it had rivers and lakes? And if it was, is there any trace of that left in the rocks? To answer that, you couldn't just land and sit still. You had to move. You had to explore. You needed wheels. And so began the era that is still unfolding today. The rovers. Not machines that glimpse Mars in a flyby or sit in one spot, but robots that drive across it day after day, year after year, standing in for human explorers on a world no human has yet reached. Each one is run by a team on Earth who come to know it almost like a person. It started small. In 1997, a lander named Pathfinder bounced onto Mars wrapped in giant airbags and released a rover the size of a microwave oven called Sojourner. It crept just a few meters over its lifetime. But it worked. And a generation watching at home realized something thrilling: we could drive on Mars. Then the rovers grew up. In 2004, twin rovers named Spirit and Opportunity landed on opposite sides of Mars, built to last 90 days. The scientist who led their science team, Steve Squires, and thousands of others poured their lives into them. And the rovers did not last 90 days. Opportunity kept driving for nearly 15 years. Spirit and Opportunity found it, the thing everyone hoped for. In the rocks and the chemistry, unmistakable evidence that liquid water had once flowed and pooled on the Martian surface. The ancient wet Mars was no longer a guess. The rovers were driving across the shores of seas that had dried up billions of years ago. Every landing, though, meant surviving the worst 7 minutes in spaceflight. A spacecraft hits the thin Martian atmosphere at thousands of kilometers an hour and has just minutes to slow from that to a gentle stop, through heat, parachutes, and rockets, completely on its own because Mars is too far away for anyone on Earth to help in real time. Engineers call it the 7 minutes of terror. By the time the radio signal reaches Earth saying the landing has begun, the spacecraft has already either survived or crashed, minutes earlier. All the mission teams can do is sit in a room, helpless, and wait to learn what already happened. It is one of the most nerve-shredding rituals in all of science. In 2012, they raised the stakes again, landing a car-sized nuclear-powered rover called Curiosity with an insane maneuver, a rocket-powered sky crane that hovered over the surface and lowered the rover on cables like a helicopter delivering cargo. It should have been impossible. It worked perfectly. And Curiosity is still driving today. Curiosity climbs a Martian mountain, drills into rock, and reads the story written in the layers. And every so often it does something wonderfully human. It reaches out its arm and takes a selfie. This is a real self-portrait, stitched together by a rover alone on the surface of Mars. And the landscape it sends back is breathtaking. Not a grainy dot, not an artist's dream, but the actual view. Layered buttes, distant ridges, a mountain of sediment built up over billions of years, all under that pale Martian sky. This is what it truly looks like to stand in an ancient crater on Mars. Curiosity found that ancient Mars had lakes of liquid water that could have been habitable, the right chemistry for long enough that life as we know it could in principle have survived there. Not proof of life, but proof that the door was open. The old question, is anything alive on Mars, had become, was anything ever alive here? And it's no longer a fantasy. It's a serious search. Which brings us to the most ambitious explorer yet. In 2021, NASA landed Perseverance, a rover built to look specifically for the fossilized signs of ancient microbial life, in a crater that was once a lake fed by a river delta. It is, in a real sense, the direct descendant of every dreamer in this story, from Lowell to Levin. This is one of its first views of Mars. Perseverance is doing something no mission has done before, drilling cores of Martian rock and sealing them in tubes, leaving them on the surface in a carefully chosen spot. The plan is for a future mission to go get them and bring them home, so that one day, for the first time, we could hold a piece of Mars in a laboratory on Earth and ask it directly whether it was ever alive. And it brought a passenger that did something out of science fiction. A tiny helicopter named Ingenuity, folded under its belly. On another planet, with air 100 times thinner than Earth's, most engineers thought powered flight was flat out impossible. In April 2021, Ingenuity lifted off, the first powered, controlled flight by an aircraft on another world. Think of the distance traveled in this story. We began with a red dot that ancient people feared as a god of death. We are now flying a helicopter through the sky of that same red dot and driving robots across its dried lake beds looking for the fossils of Martian microbes. The war god has become a field site, and even our view from home has been transformed. This is Mars as the Hubble Space Telescope sees it. Not a trembling ochre smudge that fools the eye into drawing canals, but a sharp, whole world, rusty deserts, dark volcanic plains, and bright white polar caps of ice, turning in space. So what do we finally see when we look at Mars with clear eyes? Not a god. Not a dying civilization. Not a corpse. We see a world that was once warmer and wetter, that had rivers and lakes and maybe the conditions for life, and then lost its air and its water and froze for reasons we are still working to fully understand. A cautionary tale, and a mystery, and a destination. And here's the thing worth holding on to. Every step of this story, we were wrong. We saw a war god where there was only rust. We saw canals where there were only smudges. We saw a corpse where there was a frozen, fascinating world with a watery past. Again and again, Mars humbled us. And every single time, we went anyway. That is the real lesson of the Red Wanderer. Not that humans are foolish for projecting our dreams onto the sky, but that the dreams pulled us forward, and then, one by one, we did the hard work of replacing them with something truer and more astonishing than the dreams had ever been. We turned a mirror into a map. Kepler trusted a fingernail with the sky and broke the heavens open. And patient engineers hand-colored the first picture of another planet because they couldn't wait to see it. And somewhere on Mars right now, a nuclear-powered robot is drilling rock and taking selfies alone so that one day a human might follow. Next time you're outside on a clear night, find it. That steady red point that doesn't twinkle. It's the same light the Babylonians feared, the same one Kepler fought, the same one Lowell dreamed over. And now you know it's a real place with blue sunsets and dry rivers and our robots rolling across it. We are still watching the Red Wanderer. We are just finally watching it clearly. Thank you for watching. This was the first stop in the planets, the human story of how we came to know the worlds next door. If Mars moved you, stay with us. There are 7 more waiting. Every one of them once was just a wandering light, until someone refused to stop looking.